All right, guys. So start recording has been started. So we are doing review topics for the final exam. Uh, so as I mentioned in the class on Sunday, Monday both, 11.1. Um, so first question, or you can say that question one will be true false. I think there are no multiple choice and few fill in the blanks. Okay. Fill in the blanks. So mostly covered section 11.1, which was the part of your quiz one as well, right? So basically, section one had um, simple three space, right? What we mean by three space, what is x-axis, y-axis, z-axis, what type of points are there on x-axis, right? So if there is any point on x-axis, its coordinates are a 0 0. Any point on y-axis is 0 b 0 because other two variables are 0. On z-axis, x and y are 0. So 0 0 and z will have a value c like that, right? So these are coordinate axes, and so you can add people who are coming. I think you guys can also accept the requests. And then we had plane. These were coordinate axes. So there may be a true false question like on x-axis, all the points have the form a 0 0, right? Then it will be true. Or I can say on axis, all the points are 0, B, C. It's wrong, right? On x-axis, x can be any number, not just 0. Then we had planes as well, like this z-axis and y-axis, right? They make a plane, right? So this is called YZ plane. YZ plane. And all the points on YZ plane are 0, Y, and Z. Right? X or 0 always, and because YZ plane has the equation x is equal to 0. So any question like that, on YZ plane, all points have the form 0 BC. Or on YZ plane, x is always 0, right? Like these type of things. If you have Z and X plane, on XZ plane, all points have X, Y0, and ZC. So because Y remains 0 on XZ plane. And similarly, if we have X and Y plane, a plane made with X and Y axis, right? So all the points will have X, Y, and Z will always be 0 here on XY plane, right? So these type of true false questions can be there. So the green one is XZ plane, blue one is YZ plane, and pink one is XY plane. So these type of questions can be there. Then we had a sphere, right? Sphere of radius R and center at ABC. If this is your sphere, then the equation of the sphere is x minus x naught square plus y minus y naught square plus z minus z naught square is equal to r square, right? So if the radius is r, then you have r on the right side. So I can ask you, okay, this is the equation of a sphere. Write the center and the radius. So that can be a fill in the blank type thing, right? So I can say that a sphere has radius, fill in the blank, center, fill in the blank, right? So you can write center from here and radius from here. These type of questions can be there in fill in the blanks questions. Um, there was a distance formula. Another thing was distance formula. What was that? Distance formula was if there are 2 points x1, y1, z1, and x2, y2, z2. If these 2 points are given, you can find the distance between them. The distance is square root of x2 minus x1 square plus y2 minus y1 square. plus Z2 minus Z1 square. So if I give you 2 points and ask you the radius, that can also be a fill in the blank type question. What else is there? So 1, 3 space, 2 sphere, 3 distance, and then there is another thing, which is sketching of cylindrical surfaces. Cylindrical surfaces, right? Cylindrical surfaces are easy because they have two variables at a time in their equation. If either y is equal to some function of x is given and z is missing, right? So the equation, the sketch will be, you just have to sketch this curve in xy plane. In xy plane, let's say any curve in xy plane can be this one. And because z is missing here, so it is extended in x direction. The same curve is extended in x direction like that. So it will be a cylindrical surface. For example, if there is a circle, right? Circle is x square plus y square is equal to 1, let's say. So radius is 1. So it is a circle in xy plane like that, right? This is a circle in xy plane. Because z is missing here, so you will have, it's a cylinder. It is extended in z direction, up and down both ways, right? Like that. So this becomes a cylindrical surface, okay? If there is any other curve, for example, if there is a curve between z and y, let's say, z and y. So let's say z and y, then it is extended in x direction. If there is a curve in zy plane, let's say y is equal to sine, z is equal to sine y, let's say. Right? So we know that sine y has this type of equation, right? This type of equation is sine y, right? In x and z direction, but it is a x is missing. So in 3 dimension, you have to extend it in x direction like that. So it will be similar like that, okay? It will be sine curve. So it's kind of a, you see, a paper which is folded like that, okay? In x direction like that. So it's a curve in x yz plane, but in x direction it is going, it is extended because x is missing here. So this type of small sketch you may need to draw. So these 4 things were there, and they were the part of all short questions, true false, fill in the blanks type thing, okay? Short questions. In chapter 13, I had I will do something from here, but let me finish. 13.4 and 5. 13.4 was differentials, DF, right? And 13.5 was chain rule. So I did not give a numerical question from here. I also included these in the same fill in the blanks problem, right? For example, if I ask you if fxy is given, if I say my fxy is x into cos y, right? Let's say, then what is the differential of f? So you know that differential is the derivative of f with respect to x with dx plus derivative of f with respect to y dy. So this is what you need. So if you take the derivative of fxy with respect to x, it is just cos y. So you will multiply dx with it. And with respect to y, it is x cos y has the derivative minus sine y with dy. So see the derivatives from here come here, and we just write with dx and dy. Right? So this can be a fill in the blank problem in your question 1. Okay. So I will not give you a big problem from 13.4 and 5. This is what I wrote during the lecture as well. Okay. So this is what is given in your email. I wrote in the email as well. So this is the first problem. So let's say if I can pick something from the book. Like in true false question, a question can be that the graph, I wrote this in assignment as well, right? I said these are true false questions. So for example, the graph of x square plus y square in 3 space is a circle of radius 1. This is false. Reason is that in 3 space, when one of the variable is missing, it's not a circle, it's a cylindrical surface. But because it is a circle, so when circle becomes the cylindrical surface, it is a cylinder in 3 space, not a circle, right? Because its equation is x square plus y square equal to 1 is this equation, which is in xy plane, in xy plane. And because z is missing, so it is extended in z direction. This circle is extended in z direction. So that becomes a cylinder of radius 1, not the circle. Okay, so this can be a question like that. So if you have the idea of these graphs, of course, you can answer these questions. If a point belongs to both xy plane and xz plane, then the point lies on x-axis. Yes, it is true, because you see xz plane is this one and xy plane is this one. So if a point is on xz plane and on yz plane, it means it has to be on the x-axis. Otherwise, it cannot be on both at the same time. You see, if the point is here, it is not here. And if it is here, then it is not here. But if I take a point on x-axis, it is both on xz plane and on xy plane. So see, x is common here. Xy plane, xz plane. So yes, if a point belongs to both the planes, it has to be on the common axis, which is x-axis. Okay, so that is true. So this type of things, you can expect in these type of questions also. If I write this equation and ask you the radius and center, then you have to complete the square, right? You did this in quiz 1 as well. So let's say if this type of sphere is given, x square plus y square plus z square, and then any constant here, I think it is 10x is written over there, 4y 2z plus 4y plus 2z minus 19 equal to 0. So this is a sphere. But when this is the case, I have to write sphere in this form. Otherwise, I don't know. In this form. Otherwise, I don't know what is the radius and what is the center. So I will complete the squares, x squared and 10x. I will write them together. So you can just spend 1 minute here, and then y square and 4y. You can write y square plus 4y, then z square plus 2z. So I'm leaving some space here, plus 2z, and equal to 19. I brought this 19 on the right side. Now you see, you need here plus 25. Here you need plus 4, and here you need 1 to complete the square. So I can add 25 plus 4 plus 1 on the other side as well. Now you see, this has become x plus 5 whole square. This has become y plus 2 whole square. And this has become z plus 1 whole square. And on the right, you got 49 on the right. So now you see 49 is 7 square. You see, this is 49. So 49 can be written as 7 square. So now you can write center equal to, center is 5 to 1. But because they are all with positive, so it's minus 5, minus 2, and minus 1 is the center, and your radius is 7, right? This 7 is the radius. So if I give you this equation and ask you what is the center and the radius, you can just do these 2 steps. We call them complete squares, right? By completing squares. So if you complete squares of x, y, z, right, you can easily find the radius and center. So similarly, you can pick some, for example, here in 24, x square and z square will remain as it is. Only y square will complete the square, because you see, y only has minus y in it. So x square, z square will not change. So they will have 0, 0. But y will become y square minus y, and whatever you need with that, you will get some point for y. Okay, and these are those cylindrical surfaces, because you see, one of the variable is missing. Y is equal to sine x, y x z, y x z. One of the variable is always missing. So you can draw the, for example, y is equal to ex, this one. Y is equal to ex is your, ex has this equation. E start with 1, it starts from 0 and it goes like that with x, right? So this is y is equal to ex, right? And now it should be extended in z direction. So it means it is extended in z direction. It is like that. Okay. So it's like that, right? So see, it's a paper, like folded paper type thing, right? But this goes till infinity. It does not stop, right? So this type of thing is that. So it is starting from 0 like that with x-axis it is starting and it goes to infinity. So it's a kind of a paper type thing which is folded like that. Okay. I think that's pretty much it. And what I said, if I ask you something from 13.4 and 5, I will just ask you uh, the differentials and stuff like that. So if you are adding the people, I should not worry about that, because when I listen to that sound, I go there to fill, to accept the request. But anyway, where is 13.6? So in 13.6, sorry, 13.4, not 6. 13.4 has differentials. Right. So if I compute the differential dz or dw, if there are two variables for dz is partial z by x with dx plus partial z with y with dy. That's it. So you just find two derivatives from here and put them here. And that's your answer in dx and dy. But if you have three variables, like w has three variables here, right? Then I will have another term. dw will be partial w by x with dx, dw by y with dy, plus partial w by z with dz. So see, this is the extra term because I have z in my formula. So you can find three derivatives, put them here. dx, dy, dz will remain as it is. Okay, dx, dy, dz remain as it is. So this is a simple one. Don't just spend too much time here. If you know how to write a differential, you should be all set. And this will be the part of your question one, fill in the blanks part, 1 point only. And if I ask you the chain rule, I will give you some chain rule to write, right? Simple. So you know that if z depends on x and y, you see x, y, and x and y depends on t, and they are asking you dz by dt. Right? So just remember, from Z, you can go to X, and then from X, you can go to T. So chain rule is start from Z, go to X, then start from X, go to T. Right? But same thing can be done with Y. You can go from Z to Y and then from Y to T. So you can do that as well. Z to Y and Y to T. And then we add these both. This is a chain rule. So if you know how to write a chain rule, you don't have to really memorize them. And this will also be a very short question, 1 point question. If it is there, then I will ask you in true false question that if I give you Z and XY, and I can ask you write the appropriate chain rule, and that will be it. So again, do not waste a lot of time in 13.4 and 5 because these are just short questions, couple of points in it. Okay. And main topics are from 13.6, 7, 8, and then chapter 14. So this is what I wrote here. You see, this is what I wrote here. So they are the part of question number 1. Okay, so this was question number 1. Question number 2 will be from 13.6 and 7. Okay, one question, but it will have more parts in it, maybe 2-3 parts in it, right? In 7, these are equation of plane which is tangent to the surface, right? tangent to the surface, or equation of the tangent plane to the surface, right? Plane tangent to the surface, or you can say that equation of tangent plane to the surface z is equal to fxy, right? I know that equation of plane, whether it's tangent or not, we know that equation of plane can be written as ax minus x naught plus by minus y naught plus cz minus z naught, right? Equal to 0 at x naught, y naught. So point is of course given, right? So this is what we studied in 11.7, I think. This is the problem, you see. Anyway, I think it is saved in the video. So this file is gone now. I did not save it. Did I complete the first page? I think so, right? So now you can just watch the video and complete that plane. I can start from question number 2, which I was writing. 13.67. I don't know what is wrong with that. Sometimes it just collapses. So I wrote that 2-3 parts from here. And why 2-3 parts? Because this, I left some space here. The reason is I said equation of plane that is tangent to the graph of surface z is equal to fxy at the point P. At a point P, which is x naught, y naught, z naught. And from 11.6, we know that equation of a plane is this: x minus x naught, y minus y naught, z minus z naught, c into z minus z naught equal to 0. And this is what we know from section 11.6. This is why I wrote in that sheet that 11.5 and 6 will automatically be included in 13.7. So I don't have to ask anything from there. But the problem is in 11.6, a vector which is normal vector ABC is given, and a point is also given, right? So this ABC is also given to you, so you can easily write the equation. But in 13.7, they don't give us the normal vector, right? So in 13.7, right, a normal vector is not given to us, right? Normal vector comes from the gradient. If I have a surface, like thing, right? If this is a surface that is equal to fxy, and I want to find a plane at a point that is tangent, right? That is a flat plane that only touches the surface at this point. Then the normal vector basically comes from the gradient of the function f, right? If we write the surface in this form, we should write the surface in this form: f of x, y, z equal to constant. So we should have this form of the surface. We should bring everything to one side and write equal to constant or 0, okay, at a point, this one. So I have to find this. So basically in 11.6, this vector is given, right? In 13.7, my vector is not given. Again, I think something is wrong here. Shoot. I don't know why this is having a problem. Okay, it's saved. So this is given. What is the problem? So in 11.6, it was given. That's what I'm writing. In 13.7, your n will come from f by using the gradient. So this gradient, which is the gradient will be my ABC, right? So this ABC will come from the gradient. This is the problem. ABC comes from the gradient. So that's why I left a space. 13.6 has gradient and directional derivative, right? This has gradient plus directional derivative. So I may ask you these two things directly. Oh, sorry, together, right? So that's why I left a space here. So if any surface is given, then the gradient is del f, right? Gradient is del f, which is equal to the vector which comes from the partial derivatives, partial by partial x, partial by partial y, partial by partial z. So this is the gradient of any function at a point. So that will be my ABC. So ABC will be basically coming from partial f by x, partial f by y, and partial f by z. So they will give you the normal vector. So you will have to calculate the normal vector in 11.7. So, and then the directional derivative is very easy. Directional derivative is the directional derivative of a function in the direction of a vector u. So here again, you find the gradient of f like that. You find the gradient of f and then take the dot product with your vector u. If a vector u is given, you just take the gradient dotted with u to get the directional derivative. Okay, so that's why all these things are related, and I am putting it in just one question. So this was a question of plane, right? And I can also ask you parametric equations of normal line. Parametric equations of normal line were in 11.5. Or you can say that parametric equations of line that is normal to the surface now. That is normal to the surface, means perpendicular to the surface, right? So again, if a line that is normal to the surface, let's say this is the line which is perpendicular to this surface, making a 90-degree angle, right? Right? So if it is making 90-degree angle here, I need a vector that is parallel to this line. And you see gradient of f is a vector parallel to the line. So the same which was your n is now your v, right? So if your v is ABC, then parametric equations of line, I know that from section 11.5, they are x is equal to x naught plus at, y is equal to y naught plus bt, y is equal to, I don't know why my tab is not working properly. It's sensitive or what? What is happening with this pen? Y is equal to y naught Just give me a second. Right, now it's so y naught plus bt, z is equal to z naught plus ct. I think it was very sensitive over there. So see, if a direction vector v is given and a point is given, we write like that. But in 13 point, so this vector is given in 11.5, right? But in 13.7, my v comes from the gradient vector, right? So this gradient vector will basically give me ABC, and that is in section 13.7 here. So whatever you used for the ABC for the plane, the same ABC come here. So basically this A will be partial f with x, B will be f with y, and C will be f with z, right? So this will be the equation fxt, fyt, fzt. Similarly here, this one, A becomes fx, B becomes fy, and C becomes fz. So this is the only difference between 11.56 and 13.7. So let's see if I pick something from the exercises here. Gradient vectors and directional derivative. And here they ask us the gradient, you see. So in this, you can answer the gradient. If you pick any formula here, you can find the gradient of f at the indicated point. So basically, I need to find 5x squared plus y4. Let's say fxy is 5x squared plus y4, and the point is 4, 2. You have to find the gradient. So for the gradient, I need partial derivative. And you see, I wrote in the file 13.3. If I don't, I am not asking you any question in 13.3, but you need derivatives in all this chapter 13. So derivatives come from 13.3, so you should know 13.3. So if you take the derivative, it is 10x, partial f by y is 4y3, right? So these are the partial derivatives that we studied in 13.3. So now I will put the point. So at the point 4, 2, my partial derivative with respect to x will become 10 into 4 because x is 4, and partial derivative with respect to y will become 4 into 2 cubed. So 8 times 4 is 32. So therefore, my gradient of f at the point 4, 2 will become partial f by partial x with I plus partial f by partial y 32 with j. Or you can write just 40 and 32 in this wedge bracket, right? So wedge bracket or ij, both notations can be used. If there is a z as well, you will have a third component z as well. And if they ask you the directional derivative, let's say if they ask you find directional derivative duf, right? So then u will be given. So whatever the gradient you found, take the dotted with you. So let's say this was 40, 32. And let's say any u is given, u1, u2, whatever vector is given, you just take the dot product. So 40 multiplies by u1 and 32 multiplies by u2. So that will be your directional derivative. So finding directional derivative is not a problem at all. If you have a gradient, just take the dot with you. So if you look at these questions you see here, they said find the directional derivative in the direction of u. So see, the u is given. So from here, you can find gradient of f, and then you can take the dot with u, which is given here. So that gives you the directional derivative. So these are very easy questions. But gradient also have application in equation of tangent plane and normal line, right? So for example, here, he said find the equation of the tangent plane and parametric equations of the normal line. So let's say if I pick a question from here, let's say 13.7 number 3. If the you see, if the surface is given like that, it's good. But if a surface is given like that, you have to bring z on this side. Okay, your capital fxyz is if you bring everything on one side, 4x cubed y square plus 2y minus z, right? So bring everything here. But here on the right side, if there is a constant, then no need to bring. Constant can be on the right hand side, no issue. So this is xyz 25 is equal to 25, and the point is minus 304. Right? So I can call this left hand side as fxyz. That is my capital F. On the right side, constant, no issue. If there is any xyz on the right, then I have to bring that on the left. Now, what do I need? I need the derivative of f with respect to x. I need the derivative of f with respect to y and with respect to z. So with respect to x, it is 2x. With respect to y, it is 2y. With respect to z, it is 2z, right? Now calculate all the points at 304, right? So therefore, partial f by partial x at p, right? At this p will become x is 3. So 2 into minus 3 is minus 6. Partial f by y at p is 2 into y is 0, so it is 0. And partial f by partial z at p is 2 into z is 4, so that is 8. So therefore, my gradient vector f has become partial f by partial x, which is minus 6, partial f by partial y, which is 0, and partial f by partial z, which is 8. So this is my gradient vector, which is normal vector to the plane or parallel vector to the line. So now if I write equation of tangent plane, so this equation of tangent plane, so this is my ABC, right? So this becomes my ABC, right? And this is my x naught, y naught, z naught. A given point is x naught, y naught, z naught, and the normal vector is this. So I can write a into x minus x naught plus b into y minus y naught plus c into z minus z naught equal to 0, right? So this is minus 6 into x plus 3. So minus 6x minus 18 plus 0 makes everything 0, and 8z minus 32 equal to 0. So you got 6x minus 8z equal to plus 32. 32 and 18, 70, 50, right? This is what I got. So if you divide by 2, 2 is common. 3x minus 4z plus 25. So that is your answer. This is the equation of tangent plane. And now parametric equations of normal line are x is equal to x naught plus at. So x naught is minus 3 plus a is minus 6t. Y is equal to y naught, which is 0, plus 0t, because b is also 0. And then z is equal to z naught, which is 4 and plus 8t. Right? So this becomes 0. 0 plus 0t is 0. So you can write 0 plus 0t is equal to 0. You can write that. So these are your parametric equations. And here t is a parameter which has the values in all real lines. So this is very important to write the domain of t here, because this line is infinite line. So t can take on values from minus infinity to infinity. Or you can write minus infinity is less than t is less than infinity. Or you can write t belongs to minus infinity to infinity. Okay, so these are all same, or. Write anyone. But I think t belongs to r looks good. So these are the values, these are the two questions that are important in 13.6 and 7. And as I said, I will combine them and give you one question. I may ask you in first part, find the gradient. Then I can ask you find the directional derivative, equation of tangent plane, normal line. So they are all related to each other. Is there any question? Are you guys with me or left? So recording is going on. So then we have 13.8, right? One question, question number 3 will be from 13.8. So in section 13.8, it is about relative extrema of two variables of function of two variables fx, y. Extrema means maxima and minima, right? Maxima and minima. So where my function has maxima, minima. So there are, so given a function fx, y, whatever function is given, let's say I can pick something from exercise. If you go open my notes, there are more examples and exercises as well. So here I'm picking maybe just one, but you can try more. Let's say if I do this one, y square plus xy plus 3y plus 2x plus 3. Right? So first step here is to find the critical points, because relative maxima minima always occur on critical points. So first is step 1 is find critical points. So for critical points, you need fx and fy equal to 0. Right? We set fx equal to 0 and fy equal to 0. Or any point where fx or fy does not exist. But here, these are polynomials, they always exist. You may have fx, fy does not exist. That also include. But for polynomials, it do not include. Right? Also include if any, right? If any point where my derivative becomes infinity or something, we can include that as well. But first of all, what is fx? The partial derivative with respect to x. 0 plus 1 into y plus 0 plus 2 into 1. That's it. So I will put this equal to 0. And then fy. Fy is 2y plus x, 2y plus x plus 3 equal to 0. So these are my two equations. I will solve these two. I will solve these two equations to find x and y. So from 1, you can say that y is minus 2. So I can put this in 2. Put in 2. So if I put this in 2 here, then 2 into y, right? So this is y plus x plus 3 equal to 0. So this is minus 4 plus 3 is minus 1. So my x becomes minus 1 from here. X becomes 1. Minus 1 will become 1 there. So therefore, the point is, therefore, the critical point is only one critical point I got, x1 and y minus 2. Only one critical. So that is your first step. Then step 2 is to classify whether this is minima, maxima, or saddle point. Okay. For that, we find second derivatives, fxx, which is the derivative of x with respect to x is 0. fxy, x with y is 1. fyx is also the same, 1. And then fyy is fyy is 2 plus 0, so 2. Right? So now put the point, because all these are constant, so no need. If you put the point here, they will remain the same. Put the point 1 minus 2. But because there is no x, y, z here, so they will remain the same. Then you calculate d. D is fxx, fyy minus fxy whole square. Okay, this is your d, and d has to be positive for maximum minimum. If d is negative, then you get saddle point. So fxx is 0, fxy is 1, and minus f is 2, and fxy is 1 square. So that is 0 minus 1, which is negative 1. Because it is 0, so stop. No need to do anything else. You can say that this implies d negative means that f has a saddle point at 1, 2. At this critical point, my function has a saddle point. No maxima minima there. Okay. So just so this is complete. This completes your question. But if note that if d comes out to be positive, then we also check what is fxx. If d is positive and fxx is also positive, then f has relative minima. Then f has relative minima at critical point. And if d is positive and fxx is negative, then f has relative maxima. Okay. So if d is positive, then both minima maxima comes for d positive. Okay. But then the fxx will tell you if fx is positive, then this positive gives you minima and this negative gives you maxima. And for both of them, d is always positive, because if d is negative, you have a saddle point. Okay. So this is the criteria. We did it. If you go back to my notes in 13.8, I did 2-3 examples over there. So they can also help. Okay. So this is one question. A function will be given. This function will be given. You have to find the critical points first, right? And after finding the critical points, you have to do the step 2. If there are 2 critical points, you will do this step 2 times. One for each critical point. Okay. So if there is many critical points, you will repeat this step 2 for each of the critical point, and you will decide about each critical point whether it is a saddle point or maximum minima. And if d is 0, then it's nothing. If d is 0, we cannot say, then the test fails. Okay. That then the test fails and we cannot conclude. It does not mean that there is no maxima minima there. Okay, we do not know the answer, then the test fails. Okay, so no conclusion can be made. I cannot say whether it's a maxima or minima or a saddle point. We do not know. No conclusion can be made. Okay. So these 3 questions from 13, and then in 14 we have 1, 2, 3, 4, 5. So these 1, 2, 3 were double integrals, right? This 14.5 was triple integral, And this is the application of double integral surface area, right? Application on surface area in 14.4, right? This one. And in 14.8, it is the application of triple integral, right? Application of triple integral, which gives you the mass and center of gravity type things, right? But no, it is just that. So I will ask you mostly from these three sections. It will cover two questions, okay? Question 4 and question 5. Um, so I will ask you maybe two parts each, I think. Two parts each. So there are total 4 integral problems, okay? But I may ask you two things here. One is that set up an integral. Let's say, for example, I ask you set up an integral that gives area or volume or whatever, right? That gives the area or that gives the volume, this type of thing. So it means you do not have to solve. Setup means you just have to, if it is an area problem, this is the area problem, right? So you just have to give me the limits. That's it. dy, where y goes from this limit to this limit. Dx goes from this limit to this limit. And stop. If I ask you to set up, it means just stop here. Do not solve the integral. Or if I ask you the volume problem may be a third triple integral with respect to v, right? So you know that we convert this to double integral, and first we decide about z. Z goes from bottom to top, right? And then it becomes the double integral. But then you will give me the limits of the double integral as well, right? Then dy dx, and y goes from bottom to top, left to right, right? So you have to right, and then stop here. So if I ask you just to set up an integral, do not evaluate. Just based on the region or solid, whatever is given in the question, write all the limits and stop, do not solve. Okay. And if I ask you to evaluate, let's say if I say that evaluate the integral, right? Then it means completely solve the integral. It means completely solve, do the integration and find the final answer. Okay. So this is a different, students mostly waste their time. I asked you in the question, set up an integral and they solve it completely. And at the end they say, oh, doctor, there is no time left. We could not finish the exam. Of course, you wasted a lot of time, which I did not ask. Right? So then it may become lengthy. So you have to carefully read the question. For example, here, they can ask you to find the volume, use double integral to find the volume, for example. Here they said use double integral to find the area, but they said to find the area, right? I can say that set up a double integral. I may ask you that a set up a double integral, right, to find the area of the plane region, because I just said set up, so no need to find. So just give me a double integral over the region R with respect to A and write the limits where they will go from dy dx. Okay, and then stop here. If I ask you to, I think there are volume problems as well. Double integral to find the volume, like this. Use a double integral to find the volume of the solid. So it means for that, if you use double integral for the volume, it is double integral over the region R and the surface. If you integrate a surface, this also gives you the volume under the surface, above the xy plane and within the region. So this is a tetrahedron type thing. Or here, you see, you start from bottom to the top one. So that is your top surface, right? This is your top surface. So it means you will integrate this surface. So what is z from here? You will find z. Z is 4 minus x square root, positive, right? So my volume for this question will be double integral over the region R surface, which is 4 minus x square with respect to A. Okay. When we use triple integral to find the volume, then there is nothing inside. There is no function inside here, right? This is in 14.5. Okay. But in 14.23, if you have a surface at the top, you can integrate the surface over the region R. Now, what is your region? Region is this in the first quadrant coming from the circle. So it is a quarter of a circle, you see, quarter of a circle. So you can make this circle, always make this circle separately in XY plane. So it is a quarter of a circle. It is a circle, but we are taking only the first quarter. So that is y is equal to square root of 4 minus x squared. You see from here, y is 4 minus x square root. So now I need to take the limit from bottom to the top. So this bottom is y is equal to 0 because we are in first quadrant only. So my y goes from 0 to 4 minus x square. The top is also function is also 4 minus x square dy. And then x goes from left to right. So this is a circle of radius 2. So my x goes from 0 to 2. X goes from 0 to 2 dx. So this is a setup. No need to solve. If I ask you just setup, then you just have to stop here. If I also ask you to find the volume, then you will complete this integration and find the volume. Like here, they ask you to evaluate the integral, you see, evaluate the integral. So here you have to find the integral, put the limits, get the final answer. You cannot stop anywhere. You have to integrate and find the final answer in evaluate. Like I think what questions I wrote, let's say in 14.2, 16, 21, 30. So see 16, 21. See this one. 21 is, this is evaluate the double integral. Where is the volume? Use double integral to find the volume. It was written somewhere here. This one. 3948. This one, 39. Use double integral to find the volume of the solid. So a solid bounded by the cylinder and Z0, Z3 minus X, right? (14.2) exercise 39. So they gave you a cylinder, x square plus y square equal to 9, right? And then they said z is equal to 0 means xy plane. You are above xy plane and you are below another 3 minus x. So these are the three things. Now I don't know which one is my surface. I need a top surface. So if you look at this one, z is equal to 0 is this xy plane is z is equal to 0. So this is your bottom one, right? So you are above it. So that's good. That's what you need. Z is equal to 3 minus x. Z is equal to 3 minus x is a plane that comes down in x, right? It starts from 3 and it comes down to x axis like that. Okay, so it means this is the plane on the top, and this is a cylinder which is here. You see, in xy plane. This is a cylinder with a radius 3 in xy plane. So it means this goes up, right? So it means this plane, the plane that I just made here, this plane that is coming from Z and down, it will cut my surface. You see here, it will cut my cylinder like that at the top, right? So it will cut my cylinder from the top like that. So it means my bottom surface is Z0. My top surface is this plane. My top surface is this plane. This is my top surface, right? It is not the cylinder. Cylinder is on the sides. Cylinder will give me this R because it is the side. We are inside the cylinder. So this is my top surface basically, this one. So it means my top surface have to be integrated. So my volume will be double integral over the region R, where R is this region, right? In XY plane, right? But my top surface is Z is equal to 3 minus X dA. This is my top surface, Z. This is my fxy now. So see, you have to be careful. What is my top surface? This plane becomes the top surface. And now region R will come from here, which is my circle of radius 3. So this basically gives me the region R, right? Which is x square plus y square equal to 9. Now it's your choice. You want to use polar coordinates or because in 14.2 we don't have polar coordinates, but in the exam you can do this question with polar coordinates. 14.3 are polar coordinates, and we prefer polar coordinates whenever my region has a circle. Whenever our region is circular, we prefer polar coordinates. Circular region, prefer polar coordinates. Because in polar coordinates you get very simple limits. If I don't prefer polar coordinates, then what I will do, I will draw a vertical line. So I will find these two limits. So this limit is y is equal to minus 9 minus x square, and the top limit is y is equal to plus 9 minus x square. That's the top one, and this is the bottom, right? So my limits will go from minus 9 minus x square to 9 minus x square. 3 minus x is my function and dy. And then x goes from left to right. So x starts from this left point to the right one. Because circle has radius 3, so it is from minus 3 to 3. Okay, so see, it will be little difficult, right? May not be easy. It is doable. You can do that. But if I prefer these polar coordinates, I can write this directly using polar coordinates. What is that? I will write 3 minus and dA is r dr d theta, r dr d theta, and r now goes from center to the outer radius. And my r is 3 here, you see? X square plus y square is r square. R square is equal to 9 means r is equal to 3. So for radial vector, I start from the origin and I go outwards. So see, my r goes from 0 to 3, right? And then theta. Theta starts from 0. Theta starts from 0. And because it's a complete circle, so it will come back to its original position, which is 2 pi, not 0. It is not from 0 to 0. It's from 0 to 2 pi. Okay, but now I cannot leave x as it is, right? So my x will be r cos theta. X is r cos theta, y is r sin theta. So either you can do this one, right, or you can do this one. And I think this is easy. Limits are constant, much easier to solve. Okay, and then if we ask you to complete it, you can complete and get the answer. Excuse me. So polar coordinates can also be used in a triple integral. If I ask you to evaluate again, there will be a question of evaluating. So if I ask you to evaluate, you have to integrate, find the final answer. Yz with respect to x is constant. So the integral becomes yz and x goes from -1 to z, -1 to z, right? Then you will go with y, right, z, then with respect to y. So you can complete the integral like that. But here if I ask you to use triple integral to find the volume, to find the something like that here, use triple integral to find the volume. If here you have to find the volume, but I may ask you to just set up a triple integral. Set up a triple integral that gives you the volume. So it means you just have to write the limit and stop. If I ask you to find the volume or evaluate the integral, then you will complete it. So here I think I wrote 1, 4, 9, 10. So 1, 4 is simply the integration. Limits are given. Here limits are given. You can integrate. 9 has the constant limits. You see, 9 is constant limits. So very easy. 0 to pi, 0 to 1, 0 to pi by 6, not an issue. But 9 and 10. So I think I wrote 9, 10. 10 has variable limits. 10 has variable limits, and 15, 16 also has variable limits, right? I think I wrote this problem in your practice problems. 15. 4, 9, 10, 15. I think I wrote 15, no? I think it's better if you do something from 15 as well. So use the triple integral to find the volume of the solid. So when you use that, using triple integral to find the volume of the solid without function if you integrate. Now your uh, solid is in the first octant, bounded by coordinate planes and the plane. I think I did this problem during the lecture, I think so. But anyway, 3, 6, 4, 12. 3, 6, 4, 12. Right? So, and the coordinate planes. So these three planes, he said, covered by these three planes. It means you are in the first octant. You are sitting in the room. You are sitting here. So the room which you see. But then there is a plane at your top. There is a plane at the top here. Right? So this is your top. Top is your plane, basically. Right? So it means when you write the z limits, we write the triple integral as the double integral, and we first decide about the z values, dz. So z starts from the bottom, z is equal to 0, and it goes to the top plane, this top plane, right? So my top plane is z is equal to 12 minus 3x minus 6y divided by 4. So you can find z from here. So 4, right? So 12 by 4 is 3. So z goes from 0 to 3 minus 3 by 4 x and 6 by 4 y, 3 by 2 y. Okay, so these are the limits for z and then dA outside. Now you have to see what is your dA. You see, when you have a plane at the top, basically it hits z axis, it hits y axis, and it hits x axis, right? So you have a line here. See, a plane is hitting at these on the side walls. On the left wall it creates this line, on front wall it creates this line, and on xy plane it creates this line. So this is the region on the floor. So your R region is this line. Okay, this is the region R where you are integrating this region R. So you can make this region R separately, right? You can make this region R separately. So how you can make it? You see, you have y-axis, you have x-axis, and a line which is between them. But how do you know what these 2 points are? You can put z is equal to 0, because you see this plane, this is the plane on top, but for this red line, this line, your z is 0 because it's on xy plane. So if you put z is equal to 0 here, this line will become 3x plus 6y is equal to 12 because z has become 0 here. Z equal to 0. So this line is y is equal to 12 minus 3x over 6. So 12 by 6 is 2 minus 3 by 6 is 1 by 2x. So this is my line. Okay. And what will be this point? If I put y is equal to 0, then x will be 4 is this point. Okay, because I need this point. My y coordinates start from bottom to top, and then x start from 0 to this number 4. How I got 4 here? By putting y equal to 0. If you put y 0, or you can put x and y both 0 in the plane. If you put both x and y 0, right? 4 3s are 12. So y and z equal to 0. If you put both y and z equal to 0, then your 3x will become 12. So it means x is equal to 4, right? So 3x is equal to 12 means x is equal to 4. That's how I got this point. So my y starts from, so if I write the limits now of all, so z goes from 0 to 3 minus 3 by 4x minus 3 by 4y dz. You can complete it. Then dy, y goes from 0. This see y goes from 0 to the top one. So the top is 2 minus half x. And then x goes from 0 to 4. Then if you write x at the end, x goes from 0 to 4, right? So this is the setup of an integral. These are the limits of z. These are the limits of y. These are the limits of x. So if I ask you to set up, then stop here. Stop here if only asked to set up an integral. Okay, then you stop. But if we ask you to find the volume actually, then you will continue and integrate. So let's say if I continue as an example, if I continue, I have to integrate the middle one first. Right? So here is just 1. So integral is just z. So z is from 0 to 3 minus 3x by 4, 3y by 2, right? And then dy dx. So let me complete this. It will give you a practice with the evaluation as well. So if we have to evaluate the integral, right? Then you can go like that. First, I will put the limits of z. So this will become 3 minus 3 by 4x minus 3 by 2y, and 0 will give me nothing. So now I can integrate with respect to y. So this becomes 3y minus 3 by 4 xy minus 3 by 2 y square by 2, right? So the limits of y are 0 to 2 minus x by 2. And then only one integral is left, which is dx. So now you will put the values of y, put y here, right? Put all these values, then 0, 0, 0. So 0 will not give you anything. So y will give you 3y. Y is 2 minus x by 2. Then minus 3 by 4 x, and y is 2 minus x by 2. Then minus 3 by 4 y square. Y square is 2 minus x by 2 whole square. So now I think you can simplify this first and then integrate with respect. So I think you can complete. I think I remember I did this problem during the lecture. So if you go to 14.5 lecture, you will see this example over there. So you can complete it. Okay. So now we have total 5 questions. All right. And now you know how they look like. And definitely I gave you the practice problem. Unfortunately, my first page is lost. Right. So you can just look at the video for the first page, because on the video it is captured. My file was, I think what I remember, I wrote final exam review at the top, right? And then I started. So maybe you can just write down by looking at the video. I will upload the video on YouTube and share on Moodle, right? So look at the video and complete this first page, right? Unfortunately, it got crashed and I lose the first page. All right, guys. So good luck. If you have any questions, if you do the exercises and then you feel you need more help, then you can come to my office during next week. I will be available. If I don't have duties, I will be in my office or whatever. Okay. So I hope this session helps you. You can watch this again when you have time. If you have any questions, you can ask. Otherwise, I can stop here. So I stopped the recording. So my recording